This is a long problem involving fraction. The question is long. I would encourage you to write down the question so that you can follow the solution. I believe the problem is appropriate for middle grades and high school students and teachers who are looking for challenging problems to challenge their high school and middle school students can use this problem. Um, as I mentioned 2 seconds ago, it's a long problem. The question is over 3 slides, so I would be I'll be going slowly, but it's not a bad idea to copy the question. So let me read the question to you. Interstate 55 North connects point X to point Y. Between points X and Y, there are three large cities, Arlington, Bloomington, and Covington. During rush hour in the morning, twice as many cars leave each of the three cities, Arlington, Bloomington, and Covington, and travel towards point Y as compared to the number of cars entering each city from Interstate 55. One beautiful morning during rush hour, a certain number of cars crossed point X. One-third of these cars entered Arlington. One-fourth of the total number of cars that were present between Arlington and Bloomington entered Bloomington. One-fifth of the total number of cars that were present on the highway between Bloomington and Covington entered Covington. If 6,000 cars crossed point Y that morning, how many cars crossed point X? We have a few assumptions. X and Y are just marked points on the highway, and that Arlington, Bloomington, and Covington are the only three cities between points X and Y. Cars are only traveling north, and there are no other exchanges that are taking place between points X and Y. The three exchanges that are taking place are at Arlington, Bloomington, and Covington. So let's work on the solution to the problem, just one solution. So let's summarize the problem. I have a bunch of cars here. One-third of the cars enter Arlington. However many cars enter Arlington, twice as many come out. One-fourth of the cars that were between Bloomington and Arlington enter Bloomington. Of course, twice as many cars leave Bloomington, and however many cars that were between Covington and Bloomington were here, one-fifth of them enter Covington. And of course, twice as many cars come out, and 6,000 cars were at point Y or crossed point Y. I need to find out how many cars crossed point X. That's the basic summary of the problem. Let's see how we can solve this problem. Now, recall that one-third of the cars that were here ended up going to Arlington. So I'm going to choose 3 squares to represent all the cars that crossed point X or that were here between point X and Arlington, however you want to visualize it. Again, why did I choose 3 squares? Because one-third of the cars went to Arlington. Now, what happens at Arlington? One-third of the cars went to Arlington. That's one chunk went to Arlington, but twice as many cars came out, so 2 more chunks were added. So here I should really have 4 chunks. 1, 2, 3, and 4. Now let's go over this once again. Let's erase all that. I started with 3 chunks. This represents the total number of cars. I lost Arlington, absorbed one of the squares and spat out 2 more, so I should have 4 squares here. So I have 4 squares there. What happens in Bloomington? Pretty much the same thing. You lose 1/4 of the cars. That means you lose 1 square, but you gain twice as many, so you gain 2 squares. So you lose 1 square, you gain 2 squares. So altogether, you should have 5 squares here. What happens in Covington? You lose 1/5 of these cars. That means you lose 1 square, but you do gain back twice as many, so you should gain back 2 more squares. So altogether, you should have 6 squares here. So you lose 1/5, but you gain twice as many. If you lose 1/5, you lose 1 square. You gain twice as many. You gain 2 squares. You have 4 squares plus 2 squares. You should have 6 squares here. Now, the question says these 6 squares must represent 6,000 cars, because the question says 6,000 cars crossed point Y. Well, if 6 squares represent 6,000 cars, 3 squares should represent half, or 3,000. And that's my answer. How many cars crossed point X? 3,000.